Hello, everyone. Welcome to this lecture of computer system security. Today, we are going to talk about, or we are going to continue our discussion about access control mechanisms. We've talked about discretionary-based access control, and now we are going to continue and introduce two more mechanisms, role-based and attribute-based access control that is going to finish this lecture. But before that, I'm gonna give you some heads up about some items that I guess might be important for you. Some of them I have already announced and I have sent some emails about them for you, and some others are new. For those items which are new and I'm gonna kind of share with you now, I will later send an email and put announcements on the Blackboard so that you don't kind of miss them. But I'm just giving you heads up. Okay, so the first item I want you pay attention to is the research presentation. We have research presentations kind of um, ready to be uploaded. And but the first deadline has already passed. The first deadline was on the 9th of April. And of course, you know that when I talk about multiple deadline, it means that the sooner you deliver, uh, a, a higher kind of coefficient will be applied to your actual grade, and that means that you can get, for example, 10% or 5% bonus. The normal deadline that if you apply by that time, you don't lose anything is 23rd of April. By 23rd, you should have prepared your presentation, uploaded on Blackboard, and send me the link of that uh, video, and I post that link to the Blackboard in a separate announcement. And of course, all the class are encouraged to go and watch your classmates' videos. And if you have any question about any video, you can put it in the comments, and the team members are supposed to come and answer the questions on the comment section. I personally will ask questions definitely from each of you, so you should be aware of. You should be prepared for that and make yourself ready for answering the questions in the comment section. Okay, this thing has already been emailed to you, and you're aware of that. Uh, the next thing that I'm going to share with you is about the plan for the rest of semester. So we have something about uh, 3 weeks left, unless the weeks that we are in now and you are watching these videos for. We have 3 weeks left. 2 weeks of those weeks, I'm gonna use them to cover application level security, at which we will be talking about uh, intrusion detection and firewalls, different types of intrusion detection systems, and the way they work, and also the way that firewall works, and details about firewall systems. And the very last week of the class, which is going to be the first week of May, I will be covering cloud security. But the important thing for you to know is this very last week of the class, or the very last lecture, cloud security, is not going to be asked in the exam. So I cover it, I give it I upload the video lectures like normal, and I of course encourage you to go and watch the video. And there would be attendance code for that specific video lecture as well. But I don't want to give you hard time and give you kind of introduce you items that um, they're very close to exam. So that's why the very last week of the class that I'm going to talk about cloud security here, that's not going to be asked in the exam. So you just need to watch the videos. And again, like previous previous exams we had, uh, I'll be up, I'll be uploading a series of sample questions 1 week before the end of semester, and you are encouraged to go and solve that sample questions. And we will have a consultation session on the very last week of the class I'm not sure about the date. I haven't planned for that. Right now, I'll be planning, and like I said, everything will be emailed to you and will be. I'll put them in the announcement section, so you'll see the details about it. And again, I record that video. I understand that most of you're working and you may not have time to attend the class. This is completely understandable. But at the same time, we should do it at some point. So that's why I say I pick a time, and mostly uh, for the two previous consultation sessions we had, we get something about um, 7, 8 to 10, sometimes 12 participants. And that's understandable. I understand that because you are working, some of you may not be able to attend that class. That's something that I understand. But I will be recording that session, and we solve the sample questions in that session. And I'll be open to answer any question about lecture 4 and lecture 5. Lecture 4 is going to be authentication and access control, and lecture 5 is going to be application security. And lecture 6, that, like I said, I cover cloud security, but it's not going to be asked in the exam. So you are encouraged to ask any questions about sections 4, lectures 4 and 5 on that consultation session. If you cannot attend that session, you can email me your questions, and I'll be covering your questions. And of course, after I record the video, I will upload it on Blackboard, and you can refer to Blackboard and watch the video and get your answer. Yeah, and other than that, the very last thing that I'm gonna ask you to do to plan for it is the course paper. You all have teamed up and you are working on reading some papers to do that survey uh, as a part of your research activities, as a part of your research expectation, which is great. So, but at the end of the semester, you also are asked to prepare a course paper that I have posted one post on Blackboard that gives you clue and understanding about how to write it, what include, what not include, how to format it, and the rubric of that course paper. So please refer to that document and read it carefully. It's already on Blackboard. I guess I have uploaded maybe 2-3 weeks ago. And the deadline for the course paper is the very last day of classes, 6th of May, and there is no extension for that activity, and anything after that may not be graded. And of course, you will be losing your score for that part. So please consider this deadline and talk to your teammates and plan for it in order to prepare your course paper and upload it by the time. So these were items that I wanted to share with you before getting into the course. And now, please, let's get started and continue our discussion. So we've talked about discretionary-based access control. And if you remember, I mentioned that in discretionary-based access control, we basically do things or grant accesses case by case, which means that we have, let's assume that we have m different subject or users and n different objects or resources. In that case, if you remember, we've talked about a matrix with m rows and n columns. So basically what it is case by case decision. For every access from every user to every resource or object, we decide if should be granted, if that access should be granted, or if that access should be denied. So that's why we say discretionary. And the main problem with the DAC access control is that its complexity is very high. We will end up having a matrix of O of mn, m times n, or if we assume m and n are closed, it might be O(n) squared, which is great, which is very big, and of course the complexity is high. We don't like it. And we've talked about free implementations that help us to somehow reduce that complexity. We've talked about for example, table-based or linked list based. That of course they help us to reduce that complexity, but none of them kind of will completely solve that problem. That's why we have at least two other types of access control mechanisms in the literature that today we are going to talk about. The first one is called a role-based access control mechanism. In a role-based access control mechanism, we basically define some roles, and the roles kind of determine which resources are accessible, which resources are not. For example, role one, if we look at this picture, this example here, we have three resources. Resource one, that might be a file. Resource two is a space on a disk, and resource three is another file or another resource. And we have three users. So these are subjects. If you remember, we said that in this terminology, we call these subjects, and these are objects. So we have four subjects and three objects. And here we define some rows. In this case, this is three. It might be more or less. There is no kind of obligation on the number of rows. So they might be more than number of resources, less than. There is no relation between them. But here it came to be three. So we have three rows, and the role one has only access to file one. And role two, if you look, it has access to the disk and file one, and the role three seems to be kind of has the highest kind of authority or level of access. It has access to all three resources. Excuse me. Yeah, and what we do here is we basically just assign different users or subject to the roles. Here we see that user one and two, they're assigned to role one. So when we say user one and two, they're assigned to role one, it means that user one and user two's access right are exactly kind of compliant with what we have defined in role one. So user one and two, they only have access to file one, and we don't let them to access the disk or the file number two or the last resource. And the last user kind of is defined or is assigned to role three, which means that this very last user, she will have access to all available resources we here have in this system. And this third user has kind of is assigned to two different roles. I'll be talking about it. Of course, we cannot assign this person or this user to these two roles at the same time, but there are situations that we want to change the role of a user. That's why I put these two arrows here, that to show that we can have the situations at which one user changes his role or her role, or the system basically changes the role of a user from some role to another role. And that way, of course, we change the access rights which have been previously granted to that user. Some of them may be denied hereafter, and some more or some new rights might be kind of defined for that user. So this is a kind of general description about role-based access control. And here, like I said, we define access rights with respect to the roles, not with respect to the users or subjects. And it kind of somehow follows the structure of roles or positions that we have in organizations. That's why it is better accepted by organizations. Yeah, and this is the very last thing that I've talked about. The assignment of the users to roles can be either static or dynamic according to the kind of situation or environment that we have. In a dynamic, in this case, this is of course dynamic because we want to change the role of this user, but it might be static, means that we don't want to let the users to change their role. This is a very kind of nice mechanism for access control, and NIST has kind of supported that in one of its standard, and I kind of asked for role-based access control to be covered, to be supported by systems. Okay, here is the access metrics of a role-based access control. Here we have some roles, let's say role 1 to n, and users 1 to m. These are our users. And in this table, we just say, okay, user 1 is assigned to role 1. So we put a cross here, or we put an X here, or we just say, we can just save it, whatever. This is a kind of abstract representation of the what we need to save. And of course, here the number of roles is, we expect the number of roles to be way smaller than the number of resources. So that's why OMN here is significantly smaller than OMN of the previous slide that we talked about, it about DAG-based access control. Yeah, here a relation between the, we have too many relation, one between the users and roles. When we say many to many, means that here we are talking about this line. There are some rows or some lines in our table at which a user might be assigned to more than one role. That of course makes sense. If the system is big, some roles may have nothing to do with some resources. So let's say, for example, you define few roles to address or to cover file access, and you define some other roles to cover, for example, creating a new process or killing existing process in a computer system. So, and we have, of course, a user. Let's say that user is a user of that system. That user needs a role to be able to work with the files, needs another role to be able to generate processes or kill processes. Of course, at least his or her own processes. So, so we are talking about multiple roles for a user. We are saying that there are situations at which we would like to assign more than one role to our user. So that means that the relation between the user and roles are many to many. Means that uh, more than one roles can be assigned to one user, and kind of vice versa. From the other direction, we are also have a many one-to-many relation, meaning that one role here, if you look at one column, one role can be assigned to more than one users. That's why we say this is a many-to-many relation between users and roles. The same thing between roles and objects. Roles and objects also, they kind of follow a many-to-many relation, meaning that one role can be assigned to multiple objects, or let's say multiple objects might be incorporated, might be described in a single role. So this is multiple multiple objects are getting connected to a specific role, and a single object might be described or might be addressed in more than one role. That's why we say there's a many-to-many between two cases. And like I said in the previous slide, assignment of the users to the roles might be dynamic or might be static. But the set of rules that the system follow is, sorry, the set of roles that the system would like to go with, we basically like them to be not dynamic. Which means that, for example, if we have defined 5 different roles, there are of course few cases or occasions or rare situations at which we want to, for example, upgrade our operating system and we want to define a new role regarding file access. We have owner, reader, writer, executable, executor, blah blah. And in a new update of, let's say, Windows version X, whatever, we want to define a new role. Yeah, that happens very kind of rarely, but most general, we like to keep the roles in our system, in our role-based access control, and not changing much. And object accesses or access rights associated with each role are also, we like them um, to be semi-constant, or to be changed not frequently. Okay, now let's talk about somehow an extension of role-based access control. In this extension, we are saying that we may have, like I said, we may want to somehow give more flexibility to role-based. Of course, um, we don't like to be able to, or we don't like to allow defining new roles easily. And the reason, I guess, should be obvious for you. If you let roles to be defined very easily, that might be a vulnerability. One can come and define a role with full access and then assign himself to that role, and that's it, good to go. That person might be an adversary and may access whatever you have in your system. So that's why we say that the roles, we don't like them to be defined, or new roles, we don't like them to be defined easily. But of course, we need some levels of flexibility. For that, there is a kind of option. People or researchers have defined family of role-based access control mechanism. In the family that here you see, this is an example that I'll be talking about in this few next slide. We have 4 RBACs for rule-based access control: RBAC 0, RBAC 1, RBAC 2, and RBAC 3. In RBAC 0, which is a base model, it contains the minimum functionality. And okay, we have 4 different role-based access mechanisms, and these are all together forming a kind of a family, and that family governs or controls the access control in our system. The very first one, RBAC 0, it is kind of the minimum RBAC at which we define the minimum functionality for the whole system. Users that start from here, they have some accesses based on the roles defined here, and they may access something, and some resources might not be available to them. But RBAC 1 is a kind of another role-based access control, which enables kind of inheritance. We have hierarchies here. This RBAC1 is basically, we say that it is kind of extension or inherited version of RBAC0. And here we have the option to add hierarchies between the roles of RBAC0 and RBAC1. What does that mean? I'll show you the example of this, how exactly it works, but I'm just giving you now the general idea about it. You have a role here in this RBAC1, which is inherited from a role from RBAC0. For example, you have a role in RBAC0 that has access to some files for read and write. Here you have a role which is inherited from that role, which means that it has some permissions, some access rights of that role, and some of them are not kind of inherited. For example, the role here regarding to the file access, it has only access to read because it's been inherited. It's been kind of uh, it's been a lower level kind of instance of that role. Okay, we have another family of we have another RBAC here, which enables, we call it RBAC2, and that adds constraint to the whole family, which means that uh, you wanna apply some online or some runtime constraint. Of course, you are not allowed to change the roles here, but you have some constraint here. And if you want to change something in the whole family, you just need to change your active RBAC from RBAC 0 to RBAC 1, sorry, RBAC 2. And here those constraints are being applied to the rows and of course to the users through that. And here is what I'm talking about. A user starts a session, and in that session, the user goes to one of these kind of RBACs, and in that RBACs, there are some roles, and the user pick one of them. User will be assigned to one of those roles, and the user kind of performs whatever he or she wants to do. And in the next session, or if the user needs some other permissions which are not allowed on that under the role that the user has, the system changes the session, and in the new session the user will be assigned to a different role from a different kind of RBAC, and that way the user will acquire a new set of permissions. Okay, so here we've talked about hierarchies. We have, again, if you look at this, this is of course an example. We can change it in any other thing. In RBAC 0, we don't have hierarchies. In RBAC 1, of course, we have role hierarchies. We enable role hierarchies. And through this RBAC 1, we can say that the whole family, it offers or it supports role hierarchies. In RBAC2, we enable constraints, or we let constraints. And through that, we can say the whole system kind of allows the constraint. And RBAC3, which is a kind of instantiation or a copy from these two, it is a hierarchy of these two. It both has role hierarchies and the role constraints. Okay. Now, let me give you this example that I guess makes it more clear for you how the role hierarchy works. This is a chart from some organization. We have director and two project leaders, or two project lead positions are defined to work under supervision of that director. And then lead project 1, he or she will work or will supervise engineer 1 and production engineer 1, quality engineer 1. Project leader 2 supervise production engineer 2, quality engineer 2. And from other side of this organization, we have engineering department, that they have a senior engineer or top engineer number 1 that supervise these two. So this person, production engineer, has to report to 2 persons. So this is basically the chart or organizational chart of a kind of hypothetical organization, and of course might be true for with some changes might be true for other organizations or existing organizations. So that's why we see here the hierarchies. The hierarchies are here. We have a director, and basically from the access point of view, whatever accesses quality engineer 2 has, engineer 2 also should have, because if this is a kind of if this is engineer 2 is the director or boss of quality engineer 2, whatever accesses quality engineer 2 has, engineer 2 also should have. Or whatever accesses quality engineer 2 has, project leader 2 also should have. Because that's basically how it works. Whatever accesses I have, my boss, my chair should have the same access, should have those accesses plus some other accesses that I don't have them. And that's how organizations kind of manage personnel. So we want to do the same thing in terms of access control. So we define a role from quality engineer 2, which has some set of accesses, and we define another role for engineer 2. But role engineer 2 is basically inherits or has all privileges or accesses that quality engineer 2 has. So we say that the engineer 2 inherits all accesses or all permissions from quality engineer 2. And of course, some other access rights are here for engineer 2. So here, a line between two rows implies that the upper role includes all access rights of the lower rows, as well as some other rights that might not be available to the lower role that I just talked about. Okay, how about constraint? What are the constraints? How we define constraint between the rows in order to have a family of role-based access control? We may have multiple constraints. We may come up with multiple constraints or different constraints, but some of the most important constraints are here. And constraint basically provide a means of adapting RBAC to the specific or specifications of the administration, what they want to have. The role we define, for example, might be some general roles, okay? And then administration or the organization comes and say, okay, for this role, we want to have access to, for example, if someone is role 1, we want them to have access to all printer except one specific printer. Why? Because that specific printer is, for example, in the chair's office, and we don't want anyone use that. So you see here, organizations may like to apply, may like to add a specific constraint to the roles. That's why we say there should be constraint, and the constraint, in letting constraint to be applied on the role, of course, make a role-based AC access control to be kind of a better fit for an organization. And here are types of constraint that we may think about. Of course, these are some examples. We can have more constraints. For example, mutuality of exclusive roles, which says that a user can be only assigned to one role in a session or forever. This might be a constraint. And like I said, the example I showed you in the very first slide we started, that example doesn't kind of satisfy this constraint, because that third user, if you remember, let me bring the slide again, that third user is assigned to more than one role. So in our example, this constraint is not satisfied, but we may want to have this constraint in some situation. A user can only be assigned to one role, either statically forever or just for a session, which makes it more flexible. Any permission can be granted to only one role in the set. So you have a if we have a set of roles, one permission or one access right can be granted to only one role, not more. Again, this is a constraint that we may want to have it, we might want to kind of enforce it, or we may not want. Cardinality says set the maximum number of kind of roles. So you don't want to have, let's say, infinite roles. You just want to limit the number of roles, let's say, to 50. So you put 50, and that's going to be the maximum number of roles you can define. And this is very interesting. Prerequisite roles. It says if, of course, this is kind of at odds with the other one that we here talked about, that it says roles can be assigned statically. It says if you want to change your role and go to a specific role, there should be some requirement for that new role. There are some prerequisite roles for us for some certain roles. You want to change your role from engineer quality engineer 1 to engineer 1, you should be have some roles in advance. Or let's say in this example, I can talk about it. You want to change from engineer 2, you want to change your role from engineer 2 to engineering department. You should have you should have you should have access. First, you should have gotten the role production engineer as a prerequisite. So if you don't have this role or that access is that this role has, you can't change your role from engineer to department engineering department role. So these are all constraints that can be applied to make the role-based access control more flexible and kind of more appealing to be applied to kind of big organizations with multiple departments and multiple roles. Okay, the next and the last type of access control that I'm going to talk about is called attribute-based access control, at which here we define authorization to the resources based on the condition or the properties of objects or resources, subjects, and even in some situation, the environment. What it means, it means that you don't have any kind of role here. You have some attributes. Everything has some attributes. I'm one user, I'm user 1, and I wanna access a file. I have a set of attributes with me, and those attributes define the level of my level of security, how much the system can trust me. That's being described by my attributes. For example, I'm let's say I'm originator or creator of some files. I am this is how long I've been working in this system, and some other attributes. These are all kind of attributes that describe me. And then that file also has some attributes. For example, is that a user file or a system file? Is that a readable file or executable file? And the system looks at all of these attributes, put the attributes together, and then make a decision that if this specific user should be should be allowed to access that resource or not. Here's an example, it's a kind of easy example. It says, assume that each resources has an owner attribute, which says who has generated, who has created this resource. For example, we are talking about files, and each file has an attribute that describes or specifies the name of the creator. And I want to access some file. I'm a user and I have my identity, I have my ID. I'm user A, and the generator or creator of the file that I'm going to access is also user A. What does that mean? That means that the person who wants to access that file is basically the person who has previously created that file. So if I'm the creator of a file and I later want to access that file, this seems something like normal. I have created something before and I now want to refer to it to read something or to modify whatever. So this means that if the creator which is one attribute from the file, from the resource, matches the ID of the requester or the subject, that means that the person who wants to access is the person who generated the resource or the file. So the access should be granted in this situation. But if the creator attribute on the file or on the resource doesn't match with the ID of the requester or subject, here is other attributes should be kind of investigated. So this is a kind of basic definition about attribute-based access control. And like I said, here everything is defined based on some attributes. Of course, this seems to be very flexible and very powerful. Both discretionary-based and role-based can be somehow defined as a subset of attribute-based access control. And this is very powerful, but the problem it has is the complexity. Every time we wanna, or every time a subject wants to access an object, the process of matching, or let's say evaluating the attributes of these two parties should be taken in place. So every time I'm accessing for a file, my attributes, the full set of my attributes should be read by the system. The full set of attributes of the file or the resources should be read by the system, and then the system processes these two and makes the final decision. So this is a kind of major problem or limitation of attribute-based access controls that somehow make them, at least at the time of speaking, make them infeasible. Some researchers have used them in cloud, and they used to use it in cloud systems, but like I said, the performance overhead is very high. Okay, what can be the attributes? Attribute, like I said, might be subject attributes. And we define the subject. Who is the subject? Subject is an entity that wants to access a resource, and the attribute defines the identity and characteristics of that subject. For example, the name or the ID of that subject, how long the subject is on the system, how many times the subject has, for example, deleted something or erased some resources or destroyed something, the pattern or the history of activities of that subject might be used as an attribute. For example, if I have always created files, if I have always been creating files and all of a sudden now I want to delete 100 files, that seems something odd. But that doesn't match my previous history, and that attribute doesn't that behavior doesn't match with my previous behavior. So all of these things might be defined and might be used as an attribute for the subject. The same thing, objects might be described by different attributes, and the attributes of the object can be used as leverages to make the decision. And something that we have it for the first time in attribute-based access control is the environmental attributes. In an attribute-based access control, we can define some attributes that describe the environment or the situation, the operational, technical, and even situational environment or context at which the system is working. These are all can be used as attributes that of course have been ignored in DAC and role-based access control. Yeah, and here is how an access control based on attributes works. This is a kind of scenario or the steps that takes place. In the very first step, the user or the subject requests for access to an object. And here we have a access control mechanism or access control engine. Of course, this is the engine that makes the decision, and it needs information from four different parts. The access control mechanism looks at the rules. There might be some rules in the access control mechanism, and those rules, I'll be talking about them, uh, determine, for example, if this is one rule, if the subject is the creator of the object, assign the or grant the access. This might be a rule. So some rules from this part comes to the access control mechanism. Other than that, attributes also come, attributes of the subject, attributes of the object requested, and the attributes on of the environment. These come from 3 different databases: database of subject attributes, database of object attributes, and database of environment attributes. These are all kind of being fed to the access control mechanism, and access control mechanism make the final decision, which says that, okay, permission is granted or it denies granting the permission. Okay, the system designer here can define various priorities. Of course, there might be sometimes conflicting situations. For example, we say that is this a system file? Of course, system files are important. They are operating system files, and no one should change them. Is this a system file or not? If this is a system file, don't grant the access. And here we have another thing, that's another attribute that says, is this person, is this subject the creator of that object? If this person is the creator, grant the access. So these 2 rules that come from 2 different attribute sets, they're kind of contradictory. They're in contradiction of each other. In such situations, we should proceed by having some type of priority for some attributes. We can, for example, say, okay, attributes from the object, they have higher priority than attributes coming from the subject side, or attributes coming from the environment. If the system is if the computer system is working on the kernel mode, no access should be granted to any user out of the kernel mode. So this is here, here means that we are kind of putting or giving the highest priority to the environmental factors or attributes. So, and who define these priorities? That which set has a higher priority or least priority? The system designer can do that. And then another thing is about this kind of processing that takes place here. The access control mechanism can just read the rules and implement the rules or follow the rules. This is something somehow strict and firm. Nothing can be changed, or any type of rules can be used here. For example, here we may have some probabilistic or stochastic deductions, which means that if the rule is not, or this situation is not met, we deny, for example, with the probability of 95%, and we let the person go with the probability of 5%. Of course, not for all situations this is a good thing, but for some cases that might be that may make sense, that the access control mechanism or the processing, the engine that here makes the final decision, looks at the rules, and if the rules are not exactly clear, at the end of the day, it might be something, the decision can be taken through a stochastic process or any other approach. But what it is open to the system designer. System designer can come up with different kind of mechanisms or policies that here will be used in order to process the rules and the attributes databases to make the final decision. Okay, for today's attendance code, please use this for ABAC, all uppercase, ABAC for attendance code of this video. And I think that should be enough for this recording. So we are done with our lecture 4, and we will be starting lecture 5 from the next week. Thank you for attending this video and have a good rest of the day.